Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, hello everybody. Thank you for coming, and sorry about the technical difficulties we had here. My name is Christian Luckock, and I am Director of Enterprise Architecture for OSI, which is our company, and I particularly work in Data Center and IT Solutions Group. So we're focused on taking the software we sell, applying it to the data center energy industry for solving problems around energy management, capacity planning, heating and cooling, kind of green initiatives for green IT. So that's really where my job focuses. So I go out and I help customers and partners figure out how to best use our solution and how to best architect our solution to fit their needs. So when they're building applications on top of the Pi infrastructure, I go in and help out with that. So I wasn't sure really what to expect coming to this, so I put together kind of a mix of a little bit of high level, some marketing type stuff about our company and about our software, and a little bit deeper drill down. Towards the end, I was really hoping to wrap up with a demo using one of our products. So I'd kind of like to highlight that it's a really nice kind of launching point for an application layer called AF 2.0. And I'd like to have demoed some of that, but unfortunately we're having problems connecting that to the AV projector here. So we'll figure something out. Maybe I'll turn the computer around and we'll HUD around. We'll do it kind of old school rather than having the nice big projector. But we'll see. I'd really like to make this. I hate standing up here and talking. I'd really like to make this interactive with questions. So as questions come up, if you just interrupt me, I have no issue with that. And I'd much rather make this interactive than me just standing here talking. I'm already bored of talking. So if you had any questions already, no, kidding. So we'll talk about a little bit about our company. We'll delve into we're the makers of the Pi system, and we'll talk about our software kind of from top to bottom or bottom to top. We'll start with the server, how we get data, what our interfaces are. We'll move up to the analytics layer, what we do with that data once it comes in, what you can do with it, and talk about some of our visualization techniques and applications. We'll also get into a deep dive, like I said, of the new product AF 2.0, which I think has a lot of value as an application layer to build on top of, and open for discussion as we go forward. So kind of get the marketing slides out of the way here, a quick corporate overview. Who is OSI? Has anybody here heard of us at all? Good. So hey, 3 people, half the crowd, so that's fantastic. That's good. So OSI, we are makers of the Pi system. So the Pi system, as I said, is infrastructure to manage real-time data and kind of the events and assets around that data. So we're a time series company. So this differs obviously from what you guys sell as a relational database, which is more transactional or LTP type data. This is time series data. So this is a temperature coming in from a sensor, humidity meter, vibration sensing on a generator, things of that nature. So this is kind of time streaming or data streams that are time context in nature. So, and we don't have an application. I wouldn't call us an application company by any means. We're an infrastructure. So when you buy our software and you sit down at your desk and you run setup.exe, it really doesn't do anything. It's a platform, an infrastructure on which you can then build applications. So we're a global company. We're all over the world. I know this isn't that impressive when you're Microsoft, but we're a decent-sized company of a global footprint. We have we're headquartered outside of in San Leandro, right outside the Bay Area there. Most of our development is done there, although we have development offices in Philadelphia, and a lot of development is also done in Phoenix and Germany. So we have 24/7 support. If you look at our industries here, we started off as an oil and gas company, doing work in that industry. Now kind of we break out, we do a lot in power and utilities. So all the way from power generation to transmission and distribution. Basically, if you get power into your house, it's really likely that at some point that power has been monitored somehow by the Pi system. So we're definitely the dominant player in those top 2 industries. And as you can see here, looking at this list, I mean, this is mission critical stuff. When you're talking about monitoring power grids, or you're talking about a nuclear reactor or in some sort of nuclear generation facility, It's not toy software. It has to be very robust, very secure, things of that nature. Pharmaceuticals, if you ever dealt with the pharmaceutical industries, they have a whole bunch of regulations around, hey, can you hack into this? Is it safe? Is it this? Is it that? There's things called 21 CFR Part 11, and we're all compliant with that sort of thing. So it's validated, it's secure software. And this new industry to us, though it's not that new, we've been doing IT stuff for quite some time, but we've had a really renewed focus on the data center market. And partially that's because of you guys, Microsoft. Not only are we partners with Microsoft, Microsoft is also one of our customers. So we're actually in your data centers worldwide monitoring data for what we call branch circuit monitoring, which is understanding when data comes into the data center, where does it go from there? How does the power that comes into the building go to the different racks? And that's really what we've been purchased by Microsoft to do. So as a result of that and some other dealings, we really spun off a group focused on that market. So again, a little bit of a marketing slide here. A whole bunch of customers. The Fortune 100, 500, 1,000 customers. We've been around for 25 years. So we're a privately held company, so that's a little bit rare, 25 years old. We've been profitable every year. And much like Microsoft, we invest a large hunk of our revenue back into R&D. So we're really focused on always being the cutting edge, having the best software, researching new technologies. And we have a very long-term partnership, as well as you guys being a customer, you're a strategic partner of ours. So we go to, for years now, we've been coming to the Microsoft different events, the user conferences, the dev conferences, and we're really trying to align our strategy and our product development roadmap with Microsoft's. One of the things we did, I think we're either the second or the third company ever to have VBA embedded in our product. So, we go to these meetings and we talk with you guys, we listen to you, and really try to align our strategies. This is kind of your gratuitous sort of picture of all the different company logos. Everybody has to have one of those during a presentation. Microsoft is not on there, so that's one company that's missing. But this is really based on our core verticals, of which data centers is not a complete core vertical at this point. So this is more pharma, oil, and gas companies. And this slide here, again, I apologize for a lot of the marketing stuff, but this is really why I work at OSI. If you read some of these things, it's really quite impressive. When I first came to OSI, I didn't go to OSI out of college. I worked at another company. And when I got hired at OSI, we had these user conferences. And we get all these customers together, and the customers get up on stage, and they talk to the rest of their community, their peers, about how they're getting value out of the Pi system. And I was really quite shocked at this. When I was at this conference, these people were treating the OSI company like they're rock stars. It was really kind of strange. And then when I started listening to them, the value that these companies get out of the Pi system is absolutely staggering. It's like Kodak here is a really good example. It turns out that it costs a lot of money to make the film that Kodak makes, or a lot of money in power. It's a very power-intensive operation. So at the Kodak facility, they actually have their own power generation facility right there just to power that manufacturing process. And it turns out by installing the Pi system, understanding where the energy was going, they were able to actually turn off an entire power plant. So it's tremendous savings. So this is why our customers absolutely love us, because they get visibility to this data that they never saw before. They unlock these data silos. They're able to do analysis and aggregation on this data and really find a lot of value. So the Pi system, let's talk about enough of the corporate overview. Excuse me, get a drink here. Let's talk a little bit about the Pi system. So before we get into details of that, let's talk about challenges that companies are facing today and kind of what Pi does to address these. This is pretty standard stuff. If you go to a Microsoft presentation and you look at the information worker platform that you guys sell, similar slide deck, right? So you have no visibility into operational data. You have data in silos. You have limited communication and collaboration between business groups. And those things together, along with corporate imperatives, really result in compromised quality, safety, hitting the bottom line. So OSI comes in with the Pi system to help solve some of those problems. So again, what is Pi? Pi is a system for collecting and storing process data. It's not a relational database. We're a data store that's time series in nature. It gets us infrastructure and a set of tools for building solutions on top of that. And it can be used in two ways. We initially started off, it was used by engineers and kind of people down in the trenches at the plants. But that data also gets rolled up and aggregated and used by executives and KPIs and things of that nature. Again, kind of marketing stuff. It's Scalable, that's a real key competency of us, is we can store huge volumes of data. We can store that data very quickly, and we can serve it up to many, many users at a very quick rate. We have users that are storing multiple years, 4 or 5 years of data that's coming at sub-second intervals, and they're able to pull up trends very quickly, of like a year or 90 days or 6 months of data. And really, that's really one of our core competencies, is the ability to have that engine that aggregates this data and serves it up in a very quick manner. It's highly available. We have failover technology. We can have multiple servers that speak to one another, and if a primary goes down, it fails over, much like SQL Server does. Reliable, extensible. All of our software, what I think is one of the neatest things is just like Microsoft's approach to things. There's a whole set of APIs and SDKs and ways to interact and extend our software. So if it doesn't do exactly what you can do, there's probably a way to plug in some code, write web services, whatever you need to do to extend the actual footprint of what the software can do. Obviously, it's secure and it's interoperable. We don't go in with Pi and say, hey, rip out everything you already have and put this in. That's not the point. The point is it works with existing software, aggregates that information. You have a question?
Actually, about the first bullet, the scalable. So you have like a way of quantifying that? Like, what do you mean when you say scalable?
A way of quantifying that. So what I mean by that is, we can actually store data at sub-second intervals, and we can store. I don't have any metrics for you at this point in these slides. I can get some for you if you're interested in that. But we could serve up a whole lot of data. I know it's not a technical term, in a very quick time frame. And I can show you some demonstrations of this online. We can look at some network statistics and pull up like 900 days of data, and you can see it trend very quickly. We'll get into talking about a little bit about our compression mechanisms and how we do that. Maybe that'll help out a little bit. So probably marketing slide here kind of thing, but really what we see with the Pi is you install it, you collect the data, you aggregate that data, you visualize it, you get immediate value. And then as time goes on, you start identifying projects, things like batch quality monitoring, maybe condition-based maintenance. Microsoft's using it for branch circuit monitoring. So as you find what I call these applications, you'll get more and more value out of the system as it goes. And that's really what we find. It's not like you buy it, you got the value out, you're done. It continues to add value, and it has a real life cycle in this value proposition. So let's talk a little bit about the infrastructure here. So if you look at kind of the life of a piece of data, here I got on our left a tank with a temperature sensor. And that goes into things like different SCADA systems. It goes from analog to digital, maybe PLCs, wherever that data comes from. The first touch with point with Pi is the interface level. So we have interfaces that talk to a whole bunch of devices. And this is a real sweet spot for us. We figured out a really good way to do this where it's buffered. If the connection layer between the interface and the server goes down, we'll store that information. When the connection comes back up, it syncs itself up. And really the key here is we have about 500 of these interfaces. And they range from very equipment-specific interfaces to very generic kind of standards-based interfaces. For example, XML, OPC. We have RDBMS interfaces, a generic way to talk to relational databases. To us, that's a foreign data store. So they go from, again, the specific to the generic. Once they get to the interface, they get passed off to the Pi server. And then that data, in combination with other data, relational data, maintenance data, whatever it may be, finds its way into client apps and line of business systems. So it's kind of the life cycle of a piece of data in the OSIsoft world. So if you look at our system from the top down, we'll break this up into what I'm going to call the server, the analytics, and the visuals. And we'll drill into each one of these and talk about the product offerings and what they are inside those boxes. So these are again, with Pi, it's an infrastructure. So we have the way we bundle and sell our software. There's many different pieces to each one of these boxes. The Pi archive is a key piece. We're going to talk quite a bit about Pi AF. Obviously, we have interfaces we've already talked about, and data access mechanisms. In the analytics, we have different ways that you can write code. You can do analytics against the data. You can be notified on the data. So we have a whole set of products in there. And of course, we have visualizations. We have a set of smart clients and a set of thin clients. So if you look at the server, Again, data coming in from the interfaces, and this is real-time data streaming in. We have the PyArchive, which is our data storage mechanism. And there's kind of two pieces of that. There's the snapshot piece, which is kind of a in-memory what's happening right now, and then the actual archive written to disk. We have a couple tools in here. We'll point out AF 2.0, which allows you to put metadata around that time series data and apply context in like an asset-centric sort of view. So rather than knowing where all these independent data streams are coming from, you can have these based on assets. You could have tank 1 dot, I don't know, temperature or level, rather than having to know, well, that sensor comes from here and this is what it's called. Kind of hides all the connect string sort of things behind it and applies stuff in an asset-centric manner. We have, like I said, a whole set of data access from SDKs to OLEDB providers, things like that, to get at this data in lots of different ways. So that's kind of what we'll talk about when we get to the server. Analytics, many ways to do analytics in the Pi platform, the Pi infrastructure. From kind of a syntax-based thing we call the performance equation, where you type in a little, kind of one-liner, almost a scripting type language, all the way up to what we have ACE, which is our advanced computing engine, and that's you can actually write .NET code. So you can plug in, and there's a scheduler and an eventing sort of mechanism that says, hey, when this happens, run this piece of .NET code. Of course, that kickoff web services, you can do a whole lot of stuff. So it's really open-ended and extensible when it comes to our analytics. Yeah, if you want to tie in with like SSIS or whatever you want to do here, you can. Once you're in .NET, you can do what you want. And of course, we have our notifications piece, and that's pretty critical. When you're talking about a very large amount of data, like you have here at Microsoft in your databases, it's really important to not tell someone, hey, go look at these 180,000 servers and figure out what's wrong. You need to be told, hey, server 32 is broken, or whatever it is. You want your attention drawn to the issue rather than having to hunt and search for it. And that's really the point of Pi notifications. So that can send out emails, alerts, work with different communication protocols. It can kick off web services, workflow, that sort of thing. So we'll talk a little bit about Pi notifications as well. And then you have the visuals. So we kind of group these into two pieces. We have smart clients, which are more of a the thick client type application, which we have several of, and I'll go into detail about those. And we also have a series of web parts and thin client type visualization. So one really interesting thing about our smart clients and thin clients is we have this product called ProcessBook, which is kind of Visio-like. And there's ways to then say, hey, save that ProcessBook file as SVG, scalable vector graphics file, and put it up on the portal, and it'll update in real time. So you can take what you had in a thick client and visualize it in a thin client quite easily. So let's talk a little bit about the PyArchive. Is there any questions up to this point at all? Nope. Great. So again, the key here is, this is a different world. We're in a totally different world than relational data. For instance, if you have a temperature reading coming in, and it's 65 degrees, and it comes in every second, 65, 65, 65, you don't need to store every one of those 65s. Whereas if this was a point-of-sale system, and you sold a copy of Windows Vista at $250 every second, it's really important that you capture every one of those. So it's really a different animal. So because of that kind of different paradigm, you could take advantage of different exception testing techniques and compression techniques to store the data in fidelity that's important to the user in a much more space-saving manner. So you kind of think of that as the difference between a bitmap and a JPEG, right? They both represent the same thing, because of compression and things like that. Although it looks the same, they take up a lot less space. Okay, if you want to use the bitmap, you still can. That's great. You can do it in our system too. But if you really want to take advantage of the scalability of the Pi system, you want those JPEGs. So again, a piece of data. So there's lots of different Pi data sources. We have lots of interfaces to get that. So it's really a sweet spot as we got these ways to connect the various components that then talk to the Pi server. And these are things like a flow rate from a flow meter, a batch number of a product, time contextual data. So when we talk about our data compression here, it's, again, like I said, the data compression is optional. You can turn it off. You can say, I want every piece of data that comes in to be stored. And this is highly configurable in our software. So it's really a two-step approach. There's exception testing and then compression. Exception testing happens at the interface level. Compression happens on the server. And it's the exception. Obviously, for every interface, you can change the parameters of that exception to make that exception window larger or smaller. And really what you're talking about here is filtering out noise. And different people, noise means different things. Some people want extremely, data that if it changes even a little tiny bit, I want to see it. Other people say, well, no, I don't care about that. I just want larger changes. And the same thing happens on the compression side of things. And that then is tunable on a per point basis. So when we talk about pi, we use the concept of tags or pi points. And each one of those represents one data stream coming in. So you can have a pi point called tank32.level or valve 46 pressure. And each one of those would be a pi tag. So for each one of those tags, even though they could come from the same interface, maybe it's an XML interface or an OPC interface, once a tag goes into the server, you can adjust what percentage of stuff gets compressed or not compressed. So it's really a lot of fine-grained control. So we'll talk a little bit here first about the exception test. So once events come into the interface, the raw data which comes in, there's a whole lot of different points going in here. And after the exception test, you can filter out a lot of those. So if we look at the exception test here, we have this thing called an exception deviation and an exception max time. And basically, if something falls outside of this box, then the interface will send that over to the server. And again, you can make that nothing to where everything gets sent. It's completely configurable. By default, it's 1% of what we call a span. So again, this happens on the interface level, which also helps with scalability because we're not sending as much data to the server in the first place.
Are there devices that support this pushing out predicates way into the device itself?
Sorry?
Are there any devices that are smart enough to take this kind of constraints all the way to the sensor?
Yeah, there definitely are. But I mean, a lot of this, yes, there are. Some of the SCADA systems, things like that, can handle some of this before it gets to the sensor. But then again, not everything can. So it could even be another level. So you're right. There's quite a long life cycle of data. It can go through many of these steps before we even know that it's happened and got to us. But so yes, so the answer to your question is definitely yes. One of the keys here to exception testing is when a value violates those exception tests. So we got something outside the box. We also send the previous value to the server as well. And the reason we do that is quite obvious. You can imagine here we have a value that was sent to the server, and then we're getting new values coming in, and they're inside the exception deviation. And once we get one outside, if I didn't pass this previous value back, then what we'd have is you'd see a trend line like that, which is not at all accurate. In reality, the trend line is a much more sharp increase rather than a steady increase over time. So that's why you have to send not only the value that's outside the exception, but the previous value also. It's very obvious, but some people just don't see that. So an example here of kind of walking this through time is, again, you drop stuff out that does not pass the exception test, and the other ones get pulled in. So you can see you can end up dropping out quite a bit of data over time. Boy, this should really be automated. So successive value sent to the Pi server, and when that value gets sent to the Pi server, it becomes a new snapshot value. So this is kind of an in-memory sort of value of what's happened. So when you query something, it says, hey, what is my temperature now? What is my pressure now? It looks at the snapshot table, which is data that's come into the interface and passed the exception testing. Once you pass the exception testing, it goes into the snapshot table. Yes?
So in the exception test, can you, rather than sending two parameters, can you send an equation?
Can you send a what? What was the last?
Predicate.
Like a predicate? I actually don't know the answer to that at all. I'm not sure, but I know we always send the previous value. We don't just send a predicate. We send the previous value, the entire value, and the one that's going into the snapshot.
And that's one level,
Just the previous level.
Just the previous. So it's two values. When an exception test passes, we always pass two values. Okay? So we use a swinging door algorithm once it gets past this, once it gets in the snapshot table, to determine which values are really needed to reproduce the trend. Okay, and there's kind of another level to this too. When you're visualizing a trend, if you're looking at 900 days worth of data, you don't need all those pieces of data to represent the trend, right? I mean, as you narrow down, it's kind of like the live map sort of thing. You have a big view with not as much data, and as you drill down, you get more and more data. But really what I want to talk about is at the finest grain, once you drill down all the way, how much data do we need to actually represent that trend in a reasonable way? And compression testing comes in here. So again, like I said before, this is a swinging door algorithm. You can read this for yourself. It's a value between the last archive element, event and the current snapshot is outside this box, then we violate the compression test. If that's happened, then the value previous to the current snapshot will be archived. And I'll show you again as we click through what that looks like. And again, this can all be turned off. You don't have to have this. Sometimes, some of the pharmaceutical industries you have to have every piece of data. You can't compress anything. It's all important. Other stuff is not so important, and it saves you archive space, basically. Again, the defaults are a pretty low threshold, and these can be adjusted on a per point basis. So as you see here, we have archive values coming in to the snapshot, and if one violates, then we actually archive that value. So this is the kind of the swinging door. So we get in here and get a parallelogram that moves over time, and when something goes outside of that, boom, we archive it. Okay, so what this really means then is the user requests a value in time. So give me the value of this temperature at time X, and X is not an archived event we have to interpolate. That interpolation can only ever be, can be no greater than the difference in that deviation. So raw scan values come in. After the exception, we can filter out a whole bunch of those. After compression, we can filter out even more and still get an accurate representation of what happened. And we can also interpolate along here with a reasonable degree of accuracy. And that degree of accuracy can be fine-tuned by the engineers themselves.
Are those static or can they be dynamic? For example, if I see a certain value, I want to change I'm more interested in my range is smaller, or if I start seeing another value, my range becomes bigger, kind of thing. Or is that?
Okay, so on a per point basis, so if we're looking here at temperature and then there's another one pressure, it could have a totally different set of ranges around that. If you later on you want to say, hey, I want to change that, you can't go back in time and get the data again, but you can change it going forward and change your algorithm.
I think he's referring to something more along the lines of, when you're near your temperature threshold where you raise an alert, you might want, or pressure or something, you might want to be like super accurate in that region, but maybe you don't care so much about being accurate, when you're sort of far away from hitting that.
Right.
That alarm.
Yeah, I don't believe we can do that. I don't believe we can. Now, I say that all this stuff is we have programmatic access to all of this. So if you wanted to write, some sort of service that can do that for you and say, hey, now we're at this level, change that, then you can. So again, we buffer here. So it's important that we buffer data that's already passed the exception test. So values come in, exception reporting, they go to the snapshot, and they're compressed and sent to the archive. That's a quick overview of what we just covered. So let's talk a little bit about our visualization. It's really important to be able to visualize data, and it's important to be able to pull this data up quickly. If it took, someone wanted 6 months of data and that took 20 minutes to pull up, no one's going to wait around for that data. So with these compression techniques and the ability to have both a thick client and thin client thing, we really reach a wide variety of audiences with that data, and that's absolutely critical. So again, we break it down. We have our thick clients. Process Book is the key example. And Process Book is, I don't want to call it Visio, it's like a real-time Visio. So you can imagine it's a very easy tool to use. It has a whole set of symbol libraries. It has VBA in the back if you want to actually write, call it code if you want. Obviously, we'll be moving as technology progresses to VSTA to move to the .NET world. But it allows you to quickly drag and drop symbols. In this case, you got some sort of mixer or whatever that is. Drag and drop symbols onto your screen, associate real-time values of those, draw trends. There's one thing you remember about OSI. If someone asks you, what does OSI do? We're the trend people. So if you remember that, then I think that's a good enough nutshell of what we do. So you can drop trends on here, as you can see up here. You can do level meters. You can do multi-state symbols. Things flash when you get over a certain temperature, all that kind of sort of UI, sort of HMI type feel things. And the beauty of this, since we have history for all this data, is I can click on that number there, right click and say, give me a trend of that. Give me a trend over that today. Give me a trend over that for a year. Let me look at that a week to the week before. So since we have all the history, it's very easy to pull up any screen, and we call it ad hoc trending. And of course, like I said, you can really quickly take this screen, save it to an SVG, and it becomes web-enabled. Now, another thing that's really important about this also is with tools like AF and another tool we have called Module Database, it allows you to put context around these screens. For instance, at Microsoft, you guys have a whole lot of servers in your data centers, as you can imagine. So you can imagine if you did a screen like this about a Windows server, you wouldn't want to write that screen 200,000 times. You'd want to write it once and then have some sort of tree view or drop-down list to say, hey, I'm on this unit, switch to this unit. I want the same visual information with different sets of data. So we can apply asset relative context to these screens in a very easy manner. So you create the screen once, basically reuse it a lot. So web parts, what you kind of see in the middle here is that SVG representation of a process book screen, so that can be very detailed. We also have a series of gauges and trends and tables and KPI indicators, standard stuff you'd imagine working. We've moved along with the Microsoft technologies. This is all built on top of MOS now. And it updates in real time. I mean, you sit there and the trend will move. You don't hit F5 or anything like that. It all updates in real time. We also have a set of stuff for SAP iViews as well as the Microsoft stuff. So we have pretty platform independent here on our thin client stuff. Data Link. This is one of my favorite tools. So it turns out engineers absolutely love Excel. And what we've done here is we have a plugin to Excel called Data Link, and it pulls in data in a real-time manner. And again, you can have it in that context-sensitive manner too, where you change units and it updates your data. And everything's time-based. So here on this particular report, you may have a start and end time somewhere on this screen, and you can change that and your data refreshes. If you want to look at a week's data and then say, hey, let's do this query or this whatever we're doing here, the calculations in Excel, and change that to a month, you can do that very easily. So this really opens up the full set of functionality inside the Excel tool with real-time data. Yes?
I'm getting the picture from here that all of your data is basically timestamp value.
Yeah,
Is that
that's 100% correct.
Okay.
That's 100% correct. With the exception that we have a set of metadata around those timestamp values that is asset specific. But that's what pi is. Time series data, timestamp value, timestamp value. That's exactly it. Always. Everything.
Okay.
Absolutely.
But when you compress, you only keep the timestamps of the two value at two ends, right? So you lose the timestamp for all the compressed data.
Yes.
You already dropped.
The data and the timestamp is gone. Right.
So now if someone asks for give me all the data with this timestamp, you don't know the timestamp. So you basically say that this is a friend or so.
Right. We will interpolate at that point. And based on your compression deviation, that interpolated result can only be within a certain bounds. So it's a certain percent accurate, right? It's an interpolation. You can turn that off. You don't have to. We can save every value you want. But we find, in our experience, most people will have a temperature sensor or something, it's just considered noise. They don't want to save. They definitely don't want to tell, I don't want to know when that device is reported that value doesn't change. They don't care. And they also don't want to know if that temperature has changed, 0.3 of a degree. I don't care about that. Maybe I do, maybe I don't, and you can modify that on a per point basis. But yes, once we've compressed and done exceptions, that data's gone.
Or use a SQL source?
Yeah, so we wrote our own database. Does not use a relational database. There's SQL Server is a very powerful tool. We do have software written on SQL Server. Our asset database is completely written on SQL Server 2005. But the data store itself for the time series data is not a relational database. We found to be a lot of overhead associated with that we didn't need. We needed something screaming fast that was built for one purpose and not a generic tool. So we have, well, to query our database, we have several ways to do it. We have SDKs, we have APIs, and we also have Pi OLEDB provider that will allow you to pull it in. You can even do a link server and a SQL and write SQL queries against it if you wanted to. Yes, with our OLEDB provider, you can actually write SQL queries against we'll expose it in a tabular format for you.
write queries against SQL Server, which was
You can actually make Pi look like, yeah, you can make Pi look like a Link SQL Server very easily. And you can do queries that combine the two, right?
about the same thing.
Yeah, pretty common. So again, these worksheets it can also be have the asset structure applied to them. So unit 1 versus unit 2, and all your data will update. It's kind of a common theme with our software. We also have data link for Excel services. So again, you guys came out with Excel services, and we said, oh, we'll have to do some of that. So we had the ability to push this onto the portal. Obviously, you lose some of the power of Excel. I'm sure you guys are familiar with this. It allows you to expose name ranges and things like that. You can tweak certain parameters. So True Data Link is really an engineering tool. I kind of look at this, as the marketing guy wants to see if he's getting a bonus next quarter or not. You can tweak a few values and see what the data tells him. But there's a lot of advantages to this too, right? I mean, spreadsheets are good and bad. You end up getting Excel hell or whatever they call it. Many versions of the truth, all the different marketing lingo. But that's a true statement. I have my spreadsheet with my calculations pulling in real-time data. And I give it to someone else, give it to Martin back there, and he modifies it, and everything's different, right? So that's the beauty of having all this stuff on the portal or on the web. So AF 2.0, this is before I took the job that I have right now at OSI. I was the product manager for this. So I know quite a bit about this product, and this is really a tool that again applies this asset structure or asset context around the signals coming in. And we'll talk in a little bit of detail about that because it also turns out this is a fantastic application layer on which to write software. So Jeff O'Reilly, I don't know if you guys are familiar with him, works here at Microsoft. He's going to be using this to write some software around moves, adds, and changes as this equipment changes and moves around in the data center. It really gives you a nice layer of abstraction and a great application layer. And we'll dig into this in more detail. Pi notifications. Again, that's a piece that sits on top of this asset structure and allows you to get alerts, kick off workflows, whatever you need. Kind of like processing done on the server side that says, threshold's been exceeded, send an email, sort of thing. And again, this is like all of our software. It's very, we call this infrastructure. It's completely extensible. So you can write code against it.
So when you say things like real-time event delivery and stuff like that, what assumptions are you making about the infrastructure of because you're getting sensors from a bunch of different places and you're pulling them into one place and network links can go down.
So I think probably what a better term be near real time. Yeah. So I mean clearly there's network latencies involved. If something goes down, you're not
But what do you do when things arrive late or if there's...
So if things arrive out of order to the archive, like we handle that internally, so we can figure out and put stuff kind of post-process and put things back in. If things are really late, then obviously if you have a notification based on that, that's also going to be as late. So there's not much you can do, not much we do about that at all. So when I say real time, it's it's obviously an assumption I'm making that data's coming in. It's near real time, right? I mean, you can argue real time doesn't exist at all, right?
What is the type system, the expression, the runtime look like for extensibility?
What? Okay, sorry.
The runtime, the type system, expressions, what they look like?
Okay, so for extensibility, we have a .NET SDK that you write whatever you want there. So we also have some APIs as well that aren't .NET based, but really when I see people doing a lot of this work, they do it using the .NET SDKs. Some of the client tools have VBA. We also have extensibility of our client tools, kind of like Vista and Excel, where you can add little panes. I can show you some examples of that. So it's really .NET based. We try to always be kind of on the current Microsoft thinking of how to do things. And again, we also have, like I mentioned before, the OLEDP provider that allows you to then write SQL queries if you wanted to.
Do you have a language in addition to API?
No, we don't have our own language, our own script. We have nothing like that at all. We also do a lot of batch work. So again, in the pharmaceutical industries or in food and beverage, batch is a big thing, and it's time series based, right? So you have batches that give you an event frame, start and an end, and in that start and end time are things like how fast was the mixer mixing, how much Tylenol went into the vat, that sort of stuff. So it's a big percentage of our customer base is pharmaceuticals. And that's all batch process. So you can imagine things here, trends and Gantt charts and things like that, all based on these real-time data streams.
Databases come into play when you start doing bad stuff.
They do. It becomes, event frames. We're working on our next generation of kind of the batch database, and that'll all be built on SQL Server 2005 also. Things that are meant to be in a relational database, we're not writing our own of those. I mean, we put those at the tool they belong to, and SQL Server is the right tool for that. And all of our batch stuff, I mean, I don't know how familiar you are with this 21 CFR Part 11, but it's a pretty boorish set of regulations, and they're very detailed. And these pharmaceutical companies get audited, and is this data accurate? Could it have been tampered with? And you have to pass those. They audit our company as well because these pharma companies use our software. It's quite rigorous.
Certain prescription to a particular.
Oh, absolutely. Batch lot tracing and things like that. Yes. So there's the kind of data where you have to be a little bit careful about compression, right? Did I really have that many pounds of this key ingredient, or was it this? That sort of stuff. You can't lose a lot of that data. So we have our own reporting package on top of this. It really ties into the batch stuff nicely. This is kind of our version of SQL Server reporting. The difference, or one of the key things here, is it's heavily versioned, based in time as the report changes. MCN Health Monitors, another one of our products, and this is kind of really taking the Pi infrastructure and helping IT people get up and running faster. So think of it as templates and things of that nature as they relate to monitoring your critical IT infrastructure. Pi OBA, you guys familiar with OBA? The big Microsoft push. This is Office business applications. You guys probably don't talk to marketing guys too often, but they like to talk about this. This is their buzzword of the week, is OBA. This is really kind of taking the information worker platform, Microsoft Office, and providing real-time data into it. We're working with you guys on that right now. We're going to have a new product introduction mid this year, which really ties in these different things like Data Link Server, the Excel servers. It's really more of a packaging of our software. So we've been doing this all along. We've been OBA for quite some time. There's some new stuff like the Business Data Catalog for Moss, which is a way to pull in what would be to you guys, external data into Moss for things like searching and things like that. Performance Point integration, which is a BI tool. And of course, unified communication with your communication managers and stuff like that. And that is really applying this real-time infrastructure to the Microsoft Office platform. Okay, so we kind of got through a little bit of our product offerings, talked a little bit about our compression, understand a little bit more about we're dealing with, it's different than relational data, it's signals coming in, it's stuff you can compress, stuff that can have exceptions. Let's talk a little bit about the piece that's near and dear to me, and that's AF. And I think this will be exciting to you guys. I mean, I think you guys are planning on, or at least looking at possibly writing applications using this infrastructure, correct? And that's why we're here. I think really where you want to look is this AF. So traditionally, kind of our customers have been very time series nature. They have this time series view where they have a data stream, and there's engineers out on the plant floor, and they know exactly what that Pi tag is called and what server it lives on. These guys really live in this world. Well, as we've grown as a company, and as we get to customers like Microsoft, where you have so many assets, there's hundreds of thousands of these data streams. At each one of your data centers, right now you guys have purchased the Pi system to do this branch circuit monitoring, which again is just understanding once the power comes in the door, what racks does it go to? And it's important to know that when you get to things like capacity planning. You get you get a couple hundred servers come into one of your data centers, and they say, hey, where do I put these servers? Well, in the old days, you'd go out and you'd find the rack, and you'd say, hey, that rack has 14 slots open. I'll stick 10 of them in here. Well, today these servers are so powerful that although you may have 14 slots in that rack may be at 90% power utilization. And you guys are blind to that right now, as are most companies. So branch circuit monitoring allows you to understand the power, how the power is being distributed on your data center floor to enable you to do smarter and kind of more green IT stuff, energy efficiencies, capacity planning, things of that nature. So when you're talking about the assets, the level of assets you guys have, you can't talk about, well, I need a tag with this name. It might as well be a GUID at that point because there's so many of them. What you really want to understand is you want to look at this from an asset-centric. I'm in data center Quincy up in Quincy, Washington. And I want to talk about Colo 3, rack A14, third server from the bottom, and I want its temperature. So it's really a shift away from this time series centric to more of an operation centric or context specific, a thing we call the data directory, which is one place to find all your data. Do you want to know the last maintenance data, this server? That's in SQL. What SQL server it's in? Doesn't matter. Go to AF, look up your asset model. You can find both the real time, the signals coming in, as well as relational data associated with it. So that's a big shift we're seeing. And as a result of that, we come up with a product called PyAF, and it's actually been around for a while. This is the second generation, and like I said several times now, it's a way to organize and put more meaningful context around your time series data. So we had some other tools that did this that we ran into some scalability issues because they weren't built on SQL Server, and that was a PyMDB. We did take a whack at this ourselves at one point a long time ago. But really, we started with this latest version of AF from SQL Server 2005 and built it from the ground up.
What does AF stand for?
Okay, that's a great story. So it stood for a lot of things over time. It used to be application framework, used to be analysis framework, and now it's AF. So it stands for nothing.
How about PI?
So Pi used to be process instrumentation.
Information.
Process information. And OSI used to be Oil Systems Incorporated. So we like to drop the acronyms and just go with just letters. So it's PyAF. Good question. So again, this puts organization around it. Standardization, you have version control. It really makes accessing and building things like reports or visualizations on this data a configuration exercise rather than having to have a company come in and write code for you. Although I think one of the true powers of this is the ability to write code on top of it because it has a world-class set of SDKs. You can write web services really easy on it. It's all .NET based, and it really gives you a nice level of abstraction. So I don't need to know, what's the SQL connect string to my maintenance data. What web service do I call for this? It allows you to hide all of that and then just really talk in terms of assets, computer.temperature, CPU.utilization, whatever the data stream may be. And it's extremely scalable because it's built on SQL Server 2005. We're able to do literally several million assets, each with hundreds of different attributes on them, and able to store that on a relatively low-end machine.
Do you tokenize the asset tags? Or,
Do we tokenize them?
yeah.
Not sure what you mean by that.
Whenever there's a signal from a source, we always carry, this is SQL Server 22 at Quincy database.
Yeah, so a little bit, right? So I mean, we have a concept of a tag name. If you're talking a piece of Pi data, so if you have an asset SQL Server 22, disk space left, and that would then relate and there'd be a lookup table to a Pi tag basically. So that might be could be a GUID even if you wanted it to be. It's just a string name, and that's another problem, with having those sort of names. You end up with a flat namespace, and AF really helps you get away from that flat namespace of just Pi tags on one server and allows you to abstract that into something a little more easy to understand. So just as easily as that SQL Server.disk space could come from Pi, it could also come from SQL. If you had that data, or last maintenance update, or what's the current patch, whatever that so again, it adds visibility. A little bit more of a marketing slide here. We'll skip. One really good thing is it opens up the searching functionality of SQL Server. I mean, you have all that metadata associated with it, and it really unlocks the power of searching for this data, through the SQL Server, SQL and the SQL Server tools. So before I talked about this, again, I can't highlight anymore. So we've got a fantastic application layer in which to build applications, got a great SDK. It spans multiple Pi servers, which is, we're getting away from kind of, my plant has one Pi server, to where as you move up the organization and you start talking about it from an enterprise standpoint, you could have 15 Pi servers and 48 SQL servers. But you want to know how to get to that data. Who do you even call? This helps you. This gives you one spot, one version of the truth, one spot to go.
Do you interact with System Center at all?
Sorry?
Do you interact with the System Center product at all?
Yes, so we're working with your MS-Com group to integrate with SCOM. So SCOM would be the data collection, and then we would sit behind to historize the perfbond data, CPU, memory, hard drive space.
Great. So again, like everything we do, we keep history. So as you change your asset model and you go back in time, you see it as it was. You can even plan for the future. You know you're going to add a new data center or add a new rack. You can have it to where as soon as that time hits, boom, that model's updated. It's based on, it's very simple security when you're looking at these assets. It's Windows-based security. So it's very kind of Windows Explorer sort of feel to it.
Do you do correlation as well?
So when you do a correlation, kind of like if I change X, Y happens and auto-detect that, is that what you're talking about? To some degree we do. And again, it's when you look at our analytics, you can write your own code in there. So you can do it really whatever you want in there. So that's one of the keys to this. I'm really glad you asked that. I mean, one of the reasons why you want to be able to model your data is so the computer can find correlations, right? I mean, traditionally you go into these plants and you go to some small paper mill in, I don't know, Toutle, Washington, and you get to run into this guy on the plant floor, and his name will be Fred. And Fred can look at a piece of equipment, and just by hearing it and feeling it, he can tell you when the next time it needs to be maintained. And it's humming wrong. We'll need to replace that bearing next week. And this Fred will also know if you turn this knob 3 clicks to the right, X and Y are going to happen. Or if you turn it 1 click to the left, A and B are going to happen. Well, when Fred retires, that knowledge is gone. So it's really important to capture the relationships of these assets so you can then, based on computer models, determine these correlations or have them determine them for you and alert your attention, saying, hey, this is relating to this. So that's really one of the keys to modeling this. It's a great question. So how does AF work? So again, if we look at Pi from a traditional sense, we have our time series data sources down here. Different SCADA systems, different control systems, maybe XML data, whatever it is, coming into our interface level. And again, these interfaces range from vendor-specific to generic, rolling up to a Pi server. If you take many of these now, in this case 2, and then add in what we call non-time series data sources, so this could be data coming from SQL Server, maybe these are maintenance systems, God forbid a company might have installed Oracle, they could have an Oracle server sitting around somewhere. We could pull all this data in and put it in context with your time series data and roll this up in really what I call world-class application layer that is asset equipment centric. So again, multiple Pi servers, organize your data by assets, and also pull in what we call foreign data, which to you is your world. This is relational data. So let's kind of talk about how this works. So you start with a collection of your assets, if you're a data center, we're talking HVAC units, we're talking PDUs, RPPs, racks, servers, you get down to the CPU level, you can get down to fans, whatever it is you want, ports. You associate data with those assets. When's the last time it was maintained? What's the current CPU utilization, et cetera, et cetera. And then once you create one of those assets, you templatize it. So you modeled this asset, whatever it is, a reactor or a hydrocracker or a server. Make one template of that, and then you can cookie cutter it. Create many instances you want, and it takes that data with it. Assets can be connected. They can be grouped, by function or by location. Supposing you're interested, you kind of think of this as kind of almost role-based. If you're interested in, I own this data center, you want to see things grouped by location. If you're the guy responsible for HVAC across the entire corporation, you don't want stuff grouped by location, you want to group by function, all my HVACs. Relationships get sourced, you can apply analysis. We have the terminology called cases, which is analysis over time. So given this equipment model, given this set of equipment and how it's correlated, and given this time frame, apply this analysis. What happened here? What happens if I change that? That sort of analytics you can do. And of course, this leads to visualization. Once you group all these things together, you can have visualization. And remember the data link in the process book where I change my context and the screen updates? That sort of visualization can be based off of this. So this is the point where I was going to do a demonstration until we ran into some serious AV issues. I don't know, we can probably get around this, but yeah, I don't know how well it's going to work. But what I can do is, if you guys are interested, we won't be able to record it, but I can show you on here some of the stuff we've done. But really, this is kind of where I come in and with the data center piece and where you guys have purchased it. Data centers really are kind of what we call the plant for IT. So whereas here's what would be a process book or a diagram, of a power generation facility. Data center, it can also be diagrammed. It can also be modeled. Instead of pieces of raw material going in, a product coming out, you have power going in, you have bits and bytes coming out in a data center. So it really is a process. It really is a plant. You need to look at it in a holistic view in order to monitor it. So this is actually a diagram from one of the Microsoft, one of you guys, talking about power coming in. It's a pretty simple thing, really. Power comes in, gets distributed to both critical infrastructure and non-critical infrastructure, the cooling and the mechanical distribution. It goes into CRAC units, it goes into PDUs, it goes into these power panels, and then out to the actual data center floor into the racks and servers. Kind of another way to look at this, again, another Microsoft slide, is looking at the data center from just a power distribution perspective. And if you look at all the possible different loads and where power is being used in the data center, when you get down here to pole, circuit, and rack levels, this is what Microsoft is focused on right now. And in order to do that in your data centers, to give an idea of the scale, you have about 500,000 data streams per data center. And you guys have like 14 big ones in the US and about another 5 throughout the world. So you're talking 20 data centers just for M9 at 500,000 data streams just to understand where power is going to the rack. So you can imagine how wildly, how much scalability we're going to need when you start talking about stuff like temperature and humidity. When you start pulling in.
So just to get a sense, you're saying there's
A total of 500,000 over all 20, or there's 500,000
Per.
each
Per.
one? So it's 10
10 million.
How often do they report?
I think they're doing, for the power load at the rack, I believe it's somewhere in the order of 20 seconds.
Every 20 seconds?
Yeah.
Okay, so then we're saying like 500,000 a second.
Yeah. It's not going to one server. It's going to many servers. So it's, probably we can scale out. And we have ways to make different servers communicate to the parent server if you wanted to and things of that nature. But we have a Pi server per data center. So what?
You can cover the load with about 20 servers then.
Yeah. Yeah. And once we start getting into temperature and humidity, which MS Research guys, I don't know if it's your group or what, but you developed this it'll be like a little loosely coupled network sensors that you're going to spread all throughout your data centers. And they talk to each other and create a little WAN net, and they're communicating all the time. We're going to pull all that data. We're going to pull temperature and humidity from each one of those. And there's like 5,000 or 10,000 of those, per colo, I think, in a data center. When you start talking about them monitoring data coming from the CRAC units and the cooling, and imagine getting down to the network infrastructure level. How's the traffic on my network affect my cooling? And you can really start answering those questions. This is, remember in the beginning, the marketing slides, the value now, value over time. That's really where the power of the software comes in. You've pulled data out of these separate little isolated data silos, put it in one system that you can aggregate, and you can really start seeing how X affects Y in a way you couldn't do before. So kind of interesting, the EPA sent out a report to Congress about this data center energy efficiency, and it's a problem. And basically what they said is, you need to monitor and treat your data center as like one single system. And you need to basically have real-time data and energy monitoring on that system. So this became kind of interesting to us because this is what we do. And when the EPA, I don't know if you guys are familiar with how the power industry works, but the EPA used to not regulate that. And they came out with these little warnings and said, hey, you should really do this, and then it becomes law, and suddenly you have huge fines if you don't adhere to it. So Microsoft obviously caught on to that and said, we need to get this stuff monitored.
your lobbyist is doing a great job.
He's doing a great job, yeah. He's doing a great job. And they actually recommend you have 2 years of data online. That's kind of interesting. And, when we came in and hooked up to the branch circuit monitoring systems, different hardware manufacturers actually have a little, I'd call it a little tiny data historian. And they have like 12 or 24 hours of data. And they can't go beyond that. So, we can even interface to that without interrupting the rest of the network and just pull data from there and store it long term. So it's really kind of interesting, the stuff you can do. So here's some really kind of interesting statistics about data center power, I think. This is 2005, so this is 3 years ago. So this is basically saying the power that supplied data centers could have powered 15 million typical households. I mean, it's just a massive number, right? I've actually heard even 4 and 5%, this is back in 2005, of total US electric sales went to data centers. I mean, that's a phenomenal number. And I think this is really interesting. It doubled between 2000 and 2005. They expect it to double again by 2010. And this one's great because we're in this year now. 50% of data centers won't meet their current power demands. Now, this is not a big problem for Microsoft, right? When Microsoft gets faced with this issue, what do? Well, I can tell you what they do. They go up to Quincy, Washington, which is a bean farm town. They buy up 100 acres of bean farms. They build their own substation next to a hydroelectric dam. They talk to the power company and say, this is how much we're going to pay for power for the next 10 years. They build an 11 acres of roof building, and they build a brand new 25 megawatt data center. There's quite a bit of cost involved with that. Microsoft has deep pockets. If you're a normal company, you can't do that. So what do you have to do? You have to look for efficiencies and inefficiencies, rather, inside your current infrastructure and eke out what you can. So it's a serious problem for a lot of companies. Serious problem for Microsoft. You guys have deep pockets, but you still want to control spending and improve efficiencies, obviously. So kind of Pi to the rescue. This is why we came in. So again, step one is collect the data, aggregate the data out of these disparate data silos, and provide visualization to the data. Then you get an immediate ROI on that right away. It's like, wow, I didn't know that. Oh, wow, look at this problem. And then you start building applications to solve specific problems, whether it be capacity planning, condition-based maintenance. It's a really big thing, condition-based maintenance. If you take some of the equipment, these generators inside these data centers, multi-million-dollar pieces of equipment, they cost a lot to maintain. And the manufacturer will tell you every 6 months, replace this bearing. And that could be $100,000 with labor and the cost and taking that piece of equipment offline. With condition-based maintenance, instead of doing a blind schedule of doing that every 6 months, you look at what has happened to that piece of equipment, how much has it been used, what are the different sensors in there telling you, and based on historical information and user intuitiveness, you can say, hey, that needs to be maintained tomorrow, or we can wait another 6 months, or do it earlier because it's going to break. So applications like that are very important, and it gives you a lot of ROI on top of it. So we've done quite a bit. We're in some kind of cars of the future. We're also in some planes. So kind of a lot of people think Pi is like the black box in an airplane. The only problem with that analogy is that information is only useful when the plane crashes. So I like to kind of think of Pi as TiVo for process. Rewind, see what happened. So what I'd like to do is a demo, and I don't know if I can switch over here. I don't know if we can have an AV person come out and switch me over. I have to do my function F7 here. This is going to be a little blurry, I think, so we'll do what we can with this. Is anybody going to have a seizure watching that? Is it that awful? We can either do that or I can turn my laptop around. What's preferable? I'm sorry, I don't know what's going on. This is okay? Okay. So we take a look at this. This is our Pi System Explorer. And what I've done here is I've modeled the data center. So a data center has colos inside of it. If you blink just right, it looks perfect. And inside of a colos, yeah, it's all a timing thing. Inside of a colo, you have zones, and zones are interesting because they're not physical locations, they're logical grouping of servers. So inside your data centers, have you guys ever been to one of your data centers? I highly recommend getting a tour. Honestly, the one in Quincy, it's 11 acres of roof. It's absolutely just mind-blowing how big this thing is. So inside of these data centers, you have zones. You may have a Hotmail zone or a live search zone, whatever your zone may be. And then inside of zones, you have these RPPs, which are remote power panels. These are just like the patch boards inside your house with circuits on them. Power goes through those and goes out to the individual racks. And, oops, I don't want to do that. Whatever I did, undo. Oh, no. And inside the actual racks, then obviously you have servers. So what I've done here is, I really apologize for this. I'll go through this fairly quickly here because this is quite painful. If you look at the attributes on a server, I'm going to pull that up. We have different things. We have what operating system it's running, what type of application is it running. In this case, we're running voice over IP server. You can see up there, wow, this is almost unbearable. Maybe if I shake this. I don't know. They said it was a problem with. I think it's my laptop. They said. So. Yeah, I think we should probably punt on this and maybe Yeah, maybe we can do, if you're interested, we'll take it offline without the camera on and we can search about it. But really what I want to show you is I built, based on that model, I can show you how we built some of our visualizations, some of our UI that takes advantage of that structure and automatically generates content. So I have a screen of the colo and I'm showing power used at the rack. And if you could see this, you can imagine how beautiful it looks. And as you drill down inside that colo, what's that? I might, but they're on the other computer. Yeah, that's a great idea, Martin. If you'd have thought about that an hour and a half ago, we'd be in business right now. So I've taken, basically I pointed at that database, that asset database, and I said, hey, walk those trees, walk that structure, and draw me a picture of my colo. What does it look like? Rows of racks. I wish I got on your network. Yeah, if I was part of your network. We've gone through a lot of these options in the 15 minutes of sheer terror and panic before you guys walked in the room. But unfortunately, no. What I can do is I can make these screenshots. If you guys leave me your addresses, or I'll send them to Suman, some screenshots of the application. But I was able to dynamically generate a visualization based on the topology of a colo. And in that, I showed how much power is being used at each rack. And I've color coded those with real-time data that you can then right-click and trend. It's really beautiful. And you could drill down and then say, given a rack, look at all the servers in the rack and give me statistics about that rack along with temperatures from the collection of servers inside that rack. So you can do a 3D heat model if you wanted to. And then, of course, you can drill down to a server itself. So you can go right from the kind of the big picture, drilling down to an instance of a server.
How many data streams you collect on a per server basis? You mentioned temperature.
In my demo, I'm not connecting to any real data source. Right, but the idea, Martin, are you able to? Well, thanks. You have my screenshots. Oh, that's beautiful. Martin to the rescue.
Continue on and on.
Yeah, so in my demo, I use we have some random interfaces. Remember those interfaces? We use some demo ones that generate noise, sine waves, and random data. And on each server, I think I got a little virtual machine here running on my laptop. I think I had about 15 per server, and there's close to 200,000 servers. So that's just on my laptop, and when I shut down, I'm not storing data. It's not a real server, but I have 6 months of data, again being compressed. So what I've also done is taken that data you saw that I was pointing to, which I'll show you in some screenshots. There is what type of OS it's running and what type of application it's running. Well, that data is actually based on a serial number doing a lookup in SQL. Okay, so you get real-time data coming in from my random interfaces that tells me how much power it's using. And I have SQL lookups based on a serial number of the computer telling me what is the application type I'm running on that server. And again, here I'm assuming a one-to-one relationship between server and application. And when you get into virtualization, that's not realistic, but it's a demo. And what it does is I was able to write in 20 lines of code a web service that walks based on a starting point, whether it be a colo or a rack, and says, given an application type, how much power is that application using right now? And it's 20 lines of code. I didn't have anything about connect strings. I don't know where the Pi server is. I don't know how to talk to Pi. I have a .NET SDK. It was really easy to use. That lets me walk there. Thank you, Martin, very much. Okay, so again, here's kind of where we were. I'll stand over here. With my model that I was showing you, and can you make it blink? That helps. And here I have some data coming in. So here I got serial number, real power. I got planar temperature. Some of these new servers in the motherboard, they have a bunch of sensors built in. And they have different interfaces, protocols. IPMI is one of them. And there's all kinds of power sensors and temperature sensors on the motherboard itself. And we actually did this at Cornell University on their high-performance clusters. We were able to pull that data off and store that in Pi. So they could see as usage goes up on these HPC clusters, how the temperature actually changes. What that does to the whole ambient temperature in the room, what it does to the temperature of the computers in the rack. And they've actually generated 3D heat models. And they could scroll back up and down in time and see how that room changes. So it's really quite interesting. I mean, cooling these server rooms is a big deal. And if you can improve cooling efficiencies, you save a lot of money. So, here what I've done, if you can go to the next slide, Martin. Here's that kind of top level, so go back. So based on this structure, racks the servers, racks the colo, go next slide, I was able to automatically generate this. So what I have here is this is Process Book, one of our client tools, our rich client. And what I've done is I've written .NET code. Again, remember we talked a lot about extensibility. I was able to write a plugin, just like Visto for Excel. I was able to write a little plugin here on the side of Process Book that I said basically pick a display, in this case a colo display, pick a data center out of my model. I had 5 data centers, and pick a colo. I had 3 colos per data center, or 6 colos per data center. And based on that, draw, these things look like Excel spreadsheets, right? You can go to a rack and you'll go to like AK42. And these right on the walls in these data centers, they have the labels, and like every aisle is like 6 tiles. So they lay them out just like an Excel spreadsheet. So this gives you a nice quick, and these are multi-state. So you can imagine in real time, these are changing as you're watching from red to green as power changes, or red if that's a bad status. And you can easily, since this is in Process Book, and I really wish I could show this live, I can just put my mouse over these two and hit a little button up there. It says trend. And it'll give you the real-time value of 2 pieces of these right away. And I think Martin is connecting to... Great, so let's go back while you're connecting there, Martin.
Hold on 1 second.
So what we've done here is we're using his phone modem. We're connecting to a briefing center we have, a hosted server, where we can actually pull up and take a look at this. And we'll answer some of the questions you had about how quickly can you pull up data. We have 900 days, 3 years of data from our network performance, and we'll pull that up. So next. So you can click those. You can then drill in, right? And again, here what I'm doing is I allow you, when you're talking about hundreds of thousands of assets, you get into some interesting UI paradigms. Tree view doesn't cut it very well. Traditionally, we've been a big tree view type company. So what I did was I thought that's not going to work for the data centers, too many assets. So I wrote my own kind of little cascading drop downs, right? I mean, it's a very simple paradigm, but and of course you can drill in through the other screen also. But as you drill down, you change data centers, your colo selections change, so on and so forth. And when you hit update, it very quickly walks that SQL Server relational database, pulling out all the asset information about that different rack, going then to the different data sources, whether it be SQL or Pi, to get information. Things like who's the manufacturer comes from SQL. All the data about how much power is being used comes from Pi. I also walk the child collection and fill in a visualization of where my servers are in my rack, and I pull in this IPMI, what would be IPMI data, figuring out both the ambient and planar temperature from those servers, which correlate kind of nicely to hot aisle and cold aisle. So in a data center, you have cold air getting sucked in the front and hot air being blown out the back.
Is it possible to model SQL data stream as well? For example, at that given time, this particular rack was running this application. We are doing history data, right? Later
Absolutely. Yeah.
We have different sensor ratings, and at this time, this particular server was running another application. Are you versioning the?
So there's 2 ways to look at that. If you want to say, okay, right now, so I've drilled in here another level to a server, and in this particular one, I'm running a voice over IP application, right? So that data is coming straight from SQL. If I could put that in Pi, and I could say, okay, as time changes, that goes from a voice over IP to a database server. You could do that. If it's not, if I'm just pointing to a native data source, clearly that data source has to handle that versioning. But if I put it in Pi, really anything you think is going to change with time that's of interest, put it in Pi. Okay, even string values like voice over IP or application server or database, so that's fine. Put it in Pi.
And Pi basically implements the version store on top of SQL Server.
Pi, that's one way to look at it, yes. I mean, if you had data coming in and you maybe had an RDBMS interface, so I'm pointing to SQL, and every minute I say, hey, it might change, and when I change, store the new value in Pi. You could do that.
And now that you guys understand kind of the time series aspect of Pi, the key piece here is any tag that we collect. You've seen 2 displays. One up, this is all power factor. There's some temperature and there's power. This one is the convergence, now looking at the actual performance of that IT asset. So CPU, memory, disk space, all in Pi, because it's performance data you can do by time. And that is a huge piece of converging your power by CPU or IT asset. Mm-hmm. And back to your one question, now being able to factor asset discussions or non-Pi data and putting a type, the voice over IP server, is it a SQL server? The people at MS-Com want to be able to understand in real time or historical, every time they do a security update on a Tuesday, they want to look over a time, how was that affected, if they made changes, so on and so forth.
That's great. So if we take this one step further and take a look here, so here's very small amount of code. It's like if you go to the next slide, I think it'll tell you how many lines. It's 20 lines of code, roughly, give or take. The only thing I'm missing here is like the 3 lines of code that actually call the web service. This is a little helper function I wrote against the AF SDK. And what I've basically done is, if you go to the next slide here, it writes a web service that I'm basically passing in this case, I'm limiting it, in this particular example, to a rack, and I give it an application type. And I said, based on application type, you hit invoke, it will tell you how much power, so this is using 1.986 kilowatts of power for that application. So, I mean, you think about that, it'd be quite a complicated thing. Not complicated, but it'd be a little bit more code to write if you didn't have this abstraction layer in here. You'd have to connect to SQL. First of all, you have to figure out you have to write your object model somehow. You have to group these things. So you'd have to have the relational data there. You'd also then have to query a SQL server to find out, based on this serial ID, what application am I running right now. And then you'd have to somehow have the real-time data and obviously query that. Even if you had Pi and SQL together, this level of abstraction makes it much easier. All I look at is rack dot grouping of servers, a collection of servers. Walk those collection of servers and say, hey, if application type equals this, then aggregate the power usage. Very simple. So it's a really powerful thing. So Martin, do you want to show a little bit about some real-time stuff? I really apologize for the problems of the demo here. But
Yes, the money baby. Okay.
actually came with that money. It was
Yeah.
great.
So my name's Martin, and I work with Christian, and one of the things I do is demos, I guess. So I'm live connected to a hosted demo site. This is our traditional world. People in the oil systems incorporated world would start using Pi, is taking and building a flow diagram in our Visio-like product. It's called Process Book. And really what you've got the ability to do is take data and have a tag and actually visualize it in a numerical value, some sort of blinking light. You can do it in a column that you've seen there, but you can see that everything comes back to a tag and it gives you their actual value and the timestamp. Naming convention is very important as well because you're looking at tens of thousands or maybe millions of tags. When there was a question about scalability earlier, we did show at our user conference on a Quad 4 PC a 20 million point system. And so 20 million tag system on a single server. So the scalability factor of storing and understanding data streams coming in is really what we've built the architecture around. So if I take that one...
You got a question?
20 million tags. How much of those tags they have distinct schemas?
Existing schemas.
So I think, I don't know how many different, so that really the question is how many different interfaces they have. The schema is always, again, value and timestamp. I'd have to look at the demo to understand exactly what it is, but I mean, I think that, I think we're using some of our random interfaces is what we're using.
So is every point a separate tag?
Correct.
Yes.
Yeah, every signal is a tag.
And then you can do calculations of your raw data.
So for example, if I have just one stream with say 10 different values with 10 different timestamps, there will be 10 different tags.
That's one tag.
That's one tag.
Mm-hmm.
And of course, you can have tags. When we talked about our analytics or some of the equation processing you can do, you can take those tag inputs, do some math on them or whatever, and write to another tag as an output. And you can do that calculation either on a periodic, do it every 5 minutes, or on an event. Tags 1, 2, and 3 of my 5 inputs have changed, do this processing. And you can even write .NET code to do it.
Tag independently, right?
That's correct.
So you talked about how you compress each of the tags. Right?
Yes.
Can you tell a little bit more about how you actually organize that so that you can query them efficiently? For example, in SQL you have index, so
Right.
that you can efficiently find the data.
So we have our own indexing mechanism, obviously, of Pi2, and we have 2 indexes. We have
Can you talk about a little bit about how you index those?
From a code standpoint, I don't know how well I can talk about that, to be honest with you, but I can tell you from the index, we have 2 indexes. We have tag name, and we have time. So we only have, that's the only 2 keys we have into our data store. So how they're compressed on disk, when these screens that you're looking at now that are getting real time, that comes out of our snapshot table. So it's kind of an in-memory sort of database. And then once you pull up a trend, then we're pulling obviously from disk in an archive. As far as how that works, I don't know if I can get into enough detail to help you with that. I mean, we can definitely get in touch with the right people for that, the guys who wrote the server.
So when you said that you had 20 million tags and it scaled, so what was the performance for writing the tags or retrieving the tags?
What was it from our interface perspective?
Yeah, like how much time did you take
To build the actual tags?
No, he's saying how fast does it read and write? What do we have metrics around that? Now, as far as the as far as metrics, I'm sure I can get you that. I don't have any on hand, but I think we will have some baselines on, given a certain threshold of data coming in, how long would it take to read that, given a machine spec? I'm pretty sure we have that. I don't have that with me.
And that presentation we did is on our website under a user conference, so all the specifics there, what their sampling rate, what interfaces they used, what hardware was used, and what the archive space was taken up. But what I did is I just did a tag search by name, and it came up with an alias associated with it, and then I'm able to trend that data in a trend box. So you can pull pieces up right as you need them, or I could click on multiple values here. If you notice, I do just a shift, and I can click on 3 different values and do what's called an ad hoc trend, and just trend those 3 values over each other. Since they're all sourcing the same tag, they come up with one.
Turns out it's one value.
It's sampling just fake data. But what I think would be more interesting is if we go, and now you kind of see our where OSI is in a traditional world. In the data center, I can show you a couple things from an example standpoint. You may have some questions.
Yeah, the interesting too is that same functionality where he clicked on those labels basically and said ad hoc trend. You can do that in the web as well. So it's quite flexible.
So if we go to products, and this is our deployment of Pi for our corporate internal network. So this is looking at response times. Same product, just now looking at IT data versus temperature and flow. This is my response time over the network to Montreal. And this is all live data that we've been using in production. There's the last 8 hours. And this is the quickness of the query. Let's go to 7 days. And again, as Christian pointed out earlier, being able to keep it in its high fidelity, but go back and get it very quickly. So there's 7 days worth of data. But go ahead.
Can you drill in, or are you going to go back?
I was going to drill in when I go to 900. Okay. So what I'm going to do is let's go 1,200 days worth of data.
So after compression and all of that, I don't know, this might sort of go back to the other question, but how much data are we talking about?
Yeah, it really depends too, right? I mean, that's like, it depends how much compression has occurred, and it could be that your data stream has changed once in the past 3 years. It could be that even with compression, it's changing every 3 seconds. So it's really hard to. With this data here,
5-second sampling rate. They're using an SNMP interface to talk to a router, and then that router's doing a calculation called IPSLA to give us the response time. So it's a 5-second sample, and we're bringing it back, at that same equivalent.
You're also doing the compression and all that.
we're doing exception testing at the interface level and compression at the server level. Correct. That is turned on this, and I think it's probably going to be standards. So on exception testing, the default is 1%. So 1% from kind of what we consider a default baseline. And then the compression testing is, I believe, 2%. Or maybe it's the other way around. Exception is 2 and compression is 1. But there's a small deviation. So Martin just pulled up 1,000. I thought you were going to pull up 1,200 days.
Sorry, I got it rounded up. 1,199 days.
So that was pretty fast. I mean, that actually, it took less than a minute. But the beauty of this is now is, hey, it looks like we got some interesting happen, at this high point. So Martin can pull a kind of a tracer in and say, what's the exact value here? And it looks like we had a shutdown. There's ways to turn off tags when the server reboots if you needed that. But you can pull on these traces and look at any given piece of data. And what's more exciting is you can just drill in and say, hey, based on that, drill in and let me see that here's some interesting peaks. And what does that show you? And you can keep going down. So now we've gone from 1,200 days to about 140 for 28 days now. Just by doing the drag and drop. And you can keep going and you can get to the sub-second data if you wanted to.
People have to write their plugins.
Oh, we have an SNMP interface.
And you mentioned IPMI as well.
IPMI, we don't have an exact IPMI interface, but we do have, at Cornell, we used XML to get it. So they had all this stuff running on the LAMP stack, and we used XML to query.
Many of the vendors, HP, IBM, are all revealing that now through SNMP. So Dell, through iFlow or IPMI.
That's kind of the sweet spot I was talking about. We have about 500 different interfaces, different devices. So pretty much, a lot of these things have multiple ways to get the data. Right, a lot of these HVAC and building maintenance systems, you can get stuff through BACnet or you can get it through OPC, and it's just you have to pay the vendor different money for them to expose it in different ways. So there's a way to get to it. Chances are we already have an interface for it. A lot of this stuff is moving towards OPC and generic standards like that. If we don't, we write the interface so we can crank them out pretty quickly.
One of the key things is Microsoft becoming a customer there was that we had these out-of-box library of interfaces they wouldn't have to develop, and then the scalability of Pi that could be integrated into their existing architecture for asset management, some sort of high-level reporting, whatever they've got in place, and then it lets them scale as they need to. Microsoft's on a right side of the scale. I mean, you guys are a large deployment of data centers. Not everybody's like you, from like a Boeing or a commercial grade, like say a bank or whatever. But the other thing I'll pull up to kind of finalize on the demo side is to show you what we do in SharePoint. To give you that, is that you can save the process book displays as SVGs and push them up into Microsoft SharePoint, and then we have a library of web parts as well that are interactive, and then talk to our API from the Pi system, and so update as it would in your 32-bit app.
We have a really nice integration between the thin client and the rich client, just like you guys have with Word documents posted up to SharePoint. You can view it, and you can right-click and then edit it, and then save it back up. We do the same thing with our process book and then the SharePoint application.
We're close.
So we've got an edge network here, so we're going over a pretty slow connection.
When you right click on a web page for the book application, what code running is that? Is it some JavaScript?
Oh, okay. So yeah, so on the code, a lot of the stuff is SVG based. A lot of our visualizations, so scalable vector graphics. It's an XML format. It'll be replaced by Silverlight eventually. So it's your standard DHTML, and will be Silverlight right now. It's SVG. So we're working on the Silverlight piece as we speak. So you see how things move in real time. That gauge just updated here with process utilization without refreshing. Again, this is little XML data islands going back and communicating with the server and updating the little piece of the XML graphic that it needs to. And here he just did a trend. Same sort of thing. I mean, everything to us, again, we're the trend guys. If you remember that, you'll remember what OSI does. And we're all time-based. So here we're looking at past 8 days. All you have to do is type in your range, and it can be a window, or it can be from, star indicates right now. So this is saying from -8 days to right now, show me this piece of, show me whatever this trend is. Or in this case, there's 2 trends. So here we're looking at processor utilization and how much memory is being used. They correlate? Probably not. Could they? Yes. I mean.
And then these are some of our web parts.
Yeah. So if you show here, so all this data here. So I mean these different numbers you see here, the gauge. If you right-click on the gauge, please, Martin. Again, this is a snapshot. What you're looking at now. You can right-click on any of these and say ad hoc trend, and you go from that snapshot to what does this look like over time. So I mean, all of our data has history, and that's absolutely crucial. And people say, well, what do I want to capture? Capture everything, because at some point you're going to need it. If you don't need it now, you're definitely going to need it in the future. And because with those huge amounts of data, it's really, really important to be able to organize that, to be able to search on that, and to be able to do analytics across it. Because if you get this huge amount of data and you get information overload, if you can't filter it and do the correct pivoting around it and the correct analytics on it and the correct alerting on it, it's useless.
And Christian had brought up kind of the other client tool is the add-in for Microsoft Excel. It'll give me a couple. So we'll close these. I want to view those later. Great. There we go. So if you go to the add-in, you'll see that we have a Pi add-in that allows you to access all of the data from an Excel spreadsheet. Now that we've blown past the 55,000 column limit, it really allows you to extract the data, trend it, do calculations in Excel. And many of our users are, that's all they'll use is the Excel piece. And then this is the kind of a layout, similar. So you're choosing a Pi system which you're accessing, the tag in which you're looking at, so you can see the naming. It's a SQL Server primary processor, total percent of utilization. And then you'll put the timestamp in, and then you'll fill the values out of how many days would you, since you have all this history, when would you run out of room from a capacity planning standpoint? So obviously any type of tag collected, you have that raw data. Then you can do calculations on top of that to get your average, to do any standard deviation, a number of things that you can do with, and those are written as points or tags back to the system. So you have the raw data being collected, and now the calculated data being collected as well. So that could make up that total number of 20 million. Could be raw data, but you may have a lot of calculated tags on top of it.
Another really interesting use for this data is OLAP. Right? I mean, one of the key dimensions on OLAP is time. So once you have metadata or dimensionality around that time series data with the way your assets are grouped and correlated, you can pull this data in very nicely to an OLAP cube and have some really interesting things. One of the keys to that, obviously, is your timestamps want to line up nicely to do some good multidimensional analysis. So you can do that with interpolated values, or we have interfaces that will line up times for you as needed.
Well, another piece of this is kind of opening up aspect of development on top of the platform. This was something you guys were really interested in. And this is something we allow, it's a live building in Queens University. And it allows you, let's go there. They view all the Pi data through Flash. So they write to our SDK and publish it all via Flash. And it's available to anyone that would want to go to livebuilding.queens.ca.
Not that anybody here would want to use Flash, but Silverlight.
Right, Silverlight. But you can see the extensibility aspect of it on top of Pi. They're using us as the data historian and then redoing their presentation layer. And one of the things that people really like, where we have partners that actually build the same functionality up into Earth, Microsoft Virtual Earth. Is that right, the name? Yeah, so let's say I'm BP, and I've got all these upstream areas, and I want to see them in a graphical sense and then drill into SharePoint from Virtual Earth. Our data can be replicated up into that. But so this is their main campus, and then as you hover over them, you can see, let's go here, it'll tell you total campus, and then you can go into each site, and it'll tell you what that percentage of power is being used by them, and you can go and trend it. But this is all their visual on top of the PiSense system. So it's quite nice. They're an educational institution and trying to show what they're doing for the world of green.
Again, we'll call this real-time data, but as you said, I mean, this could be a few minutes old, near real time.
Speaking about data center scenarios, most interesting aggregation that people care about is not specific tag value, but aggregation over large set, like average CPU usage for 1,000 servers, or percentile, like what's the 5% of busiest servers that we have, how can I find them? Outliers, those kind of things. Do you do that kind of analysis? Do you support it?
You bet. So think of it as setting up tags for any of those servers, and then you can massage or do analysis on any of those. One of the things that Christian brought up was something called batch or event framing. I want to look at every Monday. So it's really all event framing is stop and start time of a particular tag unit. So we want to look at all SQL servers between here and there for every Monday through the year. And then you'll see which one is an outlier. We also have something you can call the golden batch, where this is where they should be, and are they outside or inside that?
Yeah.
Another client tool that we didn't really talk about is statistical quality control. So you can actually see between your bell curve where things are rolling between. And so there's a lot of interesting things. Once you have the data, we've got tools, or we get extensible into OLAP reporting or something that he mentioned.
And you can definitely, like I said, we have that product called ACE, which allows you to actually write .NET code, so you can do whatever you want. You can say, give me all this data, either from with strict tags without AF, or with using that AF layer on top and pull that data out. And we have built-in syntaxes to do things like give me some simple statistics across a data point or a set of data points. Give me the average, give me the span, standard deviations.
Great.
So is there any questions about this? I hope this was, I know some of it was a little bit marketing and a little bit high level, but I think it's important to give you guys a little context set. And where do we come from? Who are we? I mean, we're in some pretty serious industries. I mean, it's not a toy. It definitely is a real viable piece of software that's used in mission critical applications and infrastructure, which is kind of why I wanted to give you that bit of feedback and give you an overview of what our product offerings are. And I'm sorry to say it wasn't as detailed probably as some of you would have hoped. We could maybe do something else when I can get some of the developers up here that wrote the code to even talk to you. I'm sure they'd be happy to. We've done that before in the past with some of your architects here at Microsoft.
I understand you're a privately held company.
Correct.
Any guesstimate as to what your market capitalization will be?
Yeah, there's some well, we do about 200 million in business, and so, we're up towards the billion mark, I suppose. One of the interesting things is once you get a customer with Pi, the history, they just stay.
Yeah.
And so we've taken many people from the VAX world, all the way, and now we specifically in our commercial world support just Windows, right? And it's quite interesting in the manufacturing world how many people are doing just Windows in manufacturing, where it's not people think, oh, it's a Unix world or this and that. It's primarily dominated by Windows.
And we really do tightly integrate our roadmap with you guys. I mean, even the first version you had of SharePoint, we built on top of that, and it was a disaster for a lot of reasons. But when you guys went to the next version, we said, okay, we'll stay with you. So we really tightly integrate. I mean, like I said, we're the second or third company ever to put VBA in, and that's going back a few years now. And we're moving that to VSTA, and all these other technologies come out with, we're right there.
Great.
Do you want to put our email addresses up there? That would probably be something good. If you guys want to ask some questions, if I didn't answer something correctly, I can poke the right people and get you the answers. So if you just want to maybe open up Notepad, Martin, just write our email address.
I'll put a text box right here.
Oh yeah, 'cause that's nice and readable. There we go. No, just Christian.
Are you just Christian?
Yeah, just Christian.
How did you get that?
I've gotten that good. That's my email. Just get my name is Christian Lecoq. Martin, I'm going to put yours up as well.
You want my
Yeah.
Can you give me the names of the people at Microsoft you're dealing with? The existing implementation of the ARM monitoring?
So yeah, our main contact for the data center group is Jeff O'Reilly. And what is he? Jeff O.R.
Jeff O.R.
Jeff O.R. Yeah. So Jeff's actually come and presented. Remember what I was talking about when I first started, went to these user conferences? Jeff actually came and gave a keynote about how you guys are using our software to our customer base. So he's been working with us for a couple of years now, working with several other groups. Also, we're doing a lot of, we're in joint sales pursuits with Microsoft. So for more than just a technology, from a business standpoint, we're a pretty tight partner with you guys. From a technology adoption standpoint, we're working a lot. Obviously, Jeff's group, we're working with pretty tightly. Live Labs, we're working with MS.com folks. We're working with them on the Windows Updater patching service.
It just doesn't like it. It will go back up.
You did a great job there, Martin. Thank you.
I did. That's my artwork.
So yeah, please, if you have a question, just send me an email.
Thank
Was
you.
that okay? Good. Great.